Today, we will discuss a fascinating and critical recent development in the field of artificial intelligence hardware. As AI data centers grow to handle increasingly complex tasks, their overall energy consumption has become a massive issue. We are witnessing an unprecedented global demand for raw computing power, driven by advanced machine learning models. To truly understand why energy is such a problem, we need to closely examine how these massive data centers are physically built. Currently, a typical server rack contains about 2.5 miles of traditional copper cables. These copper cables are responsible for connecting the thousands of various processors, GPUs, and memory units inside the facility. For decades, copper has been the reliable standard for transmitting data in almost all our electronic devices. However, as the sheer number of GPUs in these modern AI centers increases, the physical communication distance between them climbs. When those physical distances climb, traditional copper wiring suddenly becomes highly inefficient and problematic. Copper wires transmit data by sending electrical signals, which essentially means moving electrons physically through the solid metal. As these electrons travel over longer distances through the copper, they naturally encounter electrical resistance. This electrical resistance is a huge problem because it generates a tremendous amount of unwanted heat. Consequently, to prevent the expensive servers from overheating and melting, data centers must employ massive, industrial-scale cooling systems. Surprisingly, these heavy-duty cooling systems often consume almost as much electricity as the computer processors themselves. This combination of power loss and cooling requirements creates a severe, unsustainable bottleneck for future AI development. To solve this mounting crisis, major technology companies are actively introducing a groundbreaking new hardware design. This innovative, next-generation architecture is commonly referred to in the industry as co-packaged optics. This bold design completely replaces the heavy, heat-generating copper cables with tiny, bendable glass fibers. You might be wondering, why is this specific transition from copper to glass so incredibly important for the industry? Well, unlike traditional copper lines that transmit information using physical electrons, fiber optic cables send data in a completely different way. Instead of electricity, fiber optics transmit data as photons, which are essentially microscopic pulses of light. Moving these light photons through a strand of clear glass requires significantly less energy than pushing electrons. In fact, engineers calculate that it takes 5 to 20 times less power to move photons compared to electrons. Because there is virtually no electrical resistance when light travels through glass, very little excess heat is generated. This lack of heat means the massive, energy-hungry cooling systems can be downsized significantly, saving millions of dollars. Furthermore, it is a well-known fact of physics that fiber optics can send data far faster than copper ever could. Light naturally travels incredibly fast, allowing for much greater data bandwidth and significantly lower communication latency. This allows for near-instant, lower-latency communication between hundreds of thousands of GPUs working simultaneously on a single problem. In a modern AI data center, millions of complex mathematical calculations happen every single fraction of a second. Lower latency means that these scattered GPUs can share their mathematical results almost instantly without waiting. This high-speed synchronization is absolutely crucial for training massive large language models efficiently and effectively. Without the implementation of co-packaged optics, humanity would soon hit a hard physical limit on AI progress. Ultimately, this widespread shift from copper to glass will vastly reduce the staggering energy needs of an AI data center. It will make the entire process of training artificial intelligence more sustainable and environmentally friendly. This hardware development is widely expected to completely change the game for the entire global AI industry. It successfully paves the way for the next generation of artificial intelligence capabilities and faster processing speeds. By solving the critical energy and latency problems, engineers and researchers can focus entirely on software innovation.